Hello everybody, I'm Vincent from Alibaba. I'm glad to present the topic of YoC, an open operation system for IoT. This talk will contain 3 parts. First, I will talk through the motivation, why we want to develop such software platform in observing that the IoT era is coming. Second, I'm going to explain what is YoC, following with an introduction of YoC key functions and features. I will show you the framework and some important and useful features such as RVM-CSI, security, and so on. Then give an example to specify how to build up a smart voice operating system using the YoC software platform. Towards the very end, I will go through the user guide and how to get quickly started with YoC. As the IoT industry evolving, there are challenges we see coming up. First, the application fragmentation. We have seen tremendous amount of application emergence and become popular. Each niche market puts on some special requirements for the IoT hardware. Second, the rapid change of IoT market. We may not have an idea of what is a smart home or smart hotel a few years back. What can be done to change our everyday life got a new definition every few months, if not days. To resolve this problem, we need to have a software platform that must have the following functions or features. First, the particular software platform must be scalable and can be adapted to various IoT chips. It should be able to quickly reshift itself to cover sensor, Bluetooth, Wi-Fi, audio, and multimedia, whatever the application is. Second, it must contain domain-specific software stack to cover special functions or applications required in IoT. Being able to do AI acceleration, audio processing, mesh networking, or even motor control. Third, it must be flexible enough and easy enough to facilitate development, so that it could be significantly reduce the time to market when targeting a specific domain. Developers then can build up their designed OS based on the software platform easily and quickly. At last but not least, there should be a useful integrated designed environment for IoT development, so-called IDE, when using such a software platform. YoC is an abbreviation for Yun on Chip. Yun in Chinese means cloud. We had a big vision of all IoT devices can be capable to connect to cloud by itself, or all edge device can be managed by an IoT device service deployed in cloud. By definition, YoC could fully address the challenges mentioned previously. It provides a unified, here we named it as RVM-CSI, to be on top of various IoT chip drivers. It has been proven to be a lower density hardware abstract layer, and has been adopted and standardized by RISC-V International. We also offer an OSAL interface that can support multiple mainstream RTOS, such as FreeRTOS, RT-thread, RTOS, and so on. Most of the advantage as well as its importance. It has a rich set of middleware from which we could create domain-specific SDK easily and quickly. As of today, YoC has been well received by our customer who has deployed into their very different application scenarios. YoC is an open operation system. It consists of a component as commonly included in a software package. This code is managed in a repository that covers the basic platform, the driver, the file system, and the important features like security and the protocol stack. Other SDK for specific domain are included as well. YoC has more than 115 components so far, so we are looking forward to more developers contributing the software code into the YoC stack. So this open source platform can widely cover the domain specification use case. Thus, our community can easily deploy what they need from the big pool of resources. There is more advantage if you develop YoC with CDK, the chip design kit. CDK offers the internal web client to remotely access the OCC database and allow developers to quickly search for a similar application or solution. One can download this demo application online and demonstrate on board in a short period of time. It not only provides the GUI debug analysis tool, but also diagnostic online during the development phase. When all finished, we encourage you to contribute your new software package back to the YoC while you deploy it into your target IoT device. Let's make an example to create a smart voice operation system that could be deployed in a speaker. This particular device can be a panel or other IoT device that has audio capability. The Smart Voice OS provides services including intelligent speech recognition, multimedia service, some IoT connectivity service such as Bluetooth, Wi-Fi, an OTA service, and security service. This service could be configured in YAML script file, used to manage the software package in YoC. It also offers a lightweight multimedia framework, which could be very useful and suitable for resource-constrained SoC, which consumes less memory and is fast in response. This video demonstrates how to create a Smart Voice OS from YoC basic system through dynamically loading essential component package from OCC, which utilizes the critical edge-to-cloud integrated development mode in CDK. During watching this video, you would be able to learn more about below information or knowledge. 1. How to download CDK installer. Install and get started with CDK. 2. How to search your desired solution or demonstration application in OCC. 3. How to add a new component package into your project from OCC. Let's start now. Use your favorite browser to open OCC official website. Click Software Tool menu to open. Then download to CDK tool area. Enter the CDK introduction page by clicking For Detail button. Start to download the latest version CDK after clicking the Download button. Unzip CDK installer and double-click Setup File to install CDK as prompted. Click CDK icon in the Windows Start menu. You will see Welcome page in the center of the CDK window. You can input hello world in search box, and will find CH2601 hello world in the list of search results. Click the Create Project button and input the project name after confirming CDK started to download all component package from OCC. Click Build icon to start build. Then you can download firmware into RVM-2601 board by clicking Download icon. Open Theory Client tool and set board rate to 115 200. After pressing the reset key on the board, you will see hello world YoC string in the serial windows. That means you have already brought up YoC basic system successfully. And the welcome page again and click Component Resource button. You can select the desired AV component package by typing AV string in search box. SDK would go to download other dependent component package automatically from OCC. Then we could realize offline speech playing function by program user application. After build is done, you could download firmware into RVB-2601 board and press reset key to start. You could input a player play roll command in serial window to hear a piece of built-in music.
YoC 播放器历程。
We also can reprogram user application to support web player function, which depends on embedded TOS component package, but it doesn't exist yet. We can just download embedded TOS component package from OCC by SDK. After building is done, you could download firmware into RVB-2601 board and press reset key to start.
欢迎使用 YoC 播放器历程。
In order to make Wi-Fi function work, you should input ifconfig SSID password in serial window. Then continue to input the player play command again. You will hear a song that is downloaded from cloud and is played in local. This is all demonstration we have. If you have any questions or suggestions, please send email to cxx194832@alibaba.nc.com. We will reply them one by one. Thank you. RVM-CSI is a set of interfaces that encapsulates hardware capability and extrapolates hardware function or service to middleware, then to up layer. It got certified by TÜV last year, which fulfills the requirement of functional safety according to IEC 61508-3. To make it more convenient to the developers, we provide an AI deployment tool called HHB that can quickly convert an AI model into a C or C++ source code called CSNNN and CSI-DSP. We did a lot of work to optimize the code density as well as to improve the performance. For previous driver testing, we had gathered more than 1,800 test cases just for driver verification. Security is always a primary concern in IoT, as it becomes more and more important to protect the user privacy, sensitive data, and valuable information. As we know, IoT chips are implemented at different security levels. Name a few that we are familiar with: Secure MCU, TEE, and SE. Yet some lower price and resource constrained chip has no any other security implementation in sight. But these products still demand simple security function in practice. YoC provides a resilient security framework that could be used for this IoT chip. Developers only need simple configurations to active system security functionality automatically. Then they can deploy a rich set of security applications into the product, with respect to their security requirements. What is more, it also supports global platform TEE functionality compliance, so that the developer can migrate the security feature into YoC easier and faster. We support developers to run YoC on the Linux or Windows environment. Thanks to the T-Head Cloud Evaluation Platform, one can access RVM-2601 board via SSH. After logging remote successfully, go to get quick start with YoC by following the simple instructions in the guideline. Meanwhile, user can play with RVM-2601 using SDK. There are a lot of technical resources and documents that you could find in OCC to help experiment and continue your development. You could also buy a DUV key and run it locally. Before concluding my talk, I list some links that you find useful when you get started to play around with YoC. We encourage you to try and build your own operating system from there. Thank you for your attention.